Okay, great. So what we're going to do next is we're just going to complete solving this linear equation for y. Okay, so we have this duo variable linear equation. Okay, so this linear equation in two variables, and obviously I've worked out most of it algebraically, and so all that's left to do really is we're concentrating on the markup for this rendering. Okay, so all that's left to do is just a couple of steps here, maybe one or two, to have a solution for y. Okay, and so, yeah, so clearly we're using the math align group and the math align mark elements or tags or functions of MathML. And we've got 3 rows, one for each of the, so 3 table rows, 3 math table rows, one for each of the rows of this block derivation. All right, and we're just going to keep in mind that math align group does not is not operative or operational. Okay, so we're going to keep in mind that math align group is not operational in all rendering engines. So one way to compensate for that is just to use these sort of operation functors, Okay, so these math operator functors, okay, as spacers. Okay, so it's like a spacing function. Here's another one. Okay, so I've got 2 of them, looks like. So they're controlled around this guy here. And that makes sense because that's the longest statement in the block. Okay, in terms of character amounts per line. Okay, so let's just go ahead and set up a 4th row. Well, so far anyway, right? So the longest statement so far in this table. Okay, so let's go ahead and set up the next row. It's going to have the same basic structure as the preceding rows, right? Okay, so turns out those m rows, those math rows inside of the data cell were superfluous. So previously I think I thought I needed them for some reason or other, but yeah, seems like they were superfluous, so I just got rid of them. All right, so everything else is the same. It's just what we had was in each of these data cells was just this extra row element. Okay, the actual statement was contained inside of an additional row element, but turns out we don't need that. So gone they are. Okay, so moving right along, let's go ahead and finish up this solution for y. Okay, so that means we don't need these guys. All right, so what do we have? Well, we have on the left-hand side, obviously, we know how to do this mathematically, so we're just going to have y equals this expression in the numerator over this constant, this negative value constant. So we're just going to be dividing both sides by -4 to obtain that. Okay, so let's go ahead and do that. All right, and we'll start with, we could just copy and paste, of course, but just to sort of flesh out, just sort of get used to what's actually needed here. Okay, so next is the operator, and actually it's going to be the indicator. So next is going to be, okay, and so next is going to be the indicator, math indicator, and it's going to be just y remaining on the left-hand side, right? So math align mark edge. And let's see, this is going to be right. In fact, we'll go ahead and change that for each of the y's. Okay, which are all sort of rightmost aligned here. Okay. And the closing tag for the indicator. Cool. Okay, so now we have our y mapped out. And then next, we need our equal sign. malignGroup. All right. That's going to be malignmark edge center. Okay. And we'll just put the equal sign character inside there. And make sure that we have the opening tag for the operator. All right, so there we go. All right. And so as it is, that's almost perfectly aligned, but of course we have some more characters to add. Okay, so next what we need is a fraction, isn't it? Okay, so let's go ahead and make sure that we write out the fraction. It is also going to be an aligned group, but what we're going to need to do is to make sure that everything is in order. Let's just start out by writing out the fraction. Okay, so and then we'll deal with the alignments afterwards. Okay, and so of course, for a math fraction, we really just need to know what are the numerators and what are the denominators. And in this case, because they are algebraic expressions, we're going to put them inside of rows. So that's going to be our numerator, and this will be our denominator. Cool. So what is the numerator made of, or comprised of? Well, it's really just this expression here. So of course, we would just save time and copy that from here, looks like, or even from here. And yeah, so let's go ahead and just do that. Got a little bit of warm up. Okay. With this leverolateral term or expression. So now we'll make sure that this guy is aligned correctly. Okay, looks good. So that's our numerator. And one thing we might just do before we even put in the denominator, just go ahead and say display style true. Okay, just to get that little bit of extra white space for legibility. Cool. And then next, let's go ahead and put in the denominator. All right, and what do we need? We just need -4, right? So we'll go ahead and grab this prefix. In fact, we'll just go ahead and grab both of these guys. Okay, and just as a reminder, MathML and really XML, sorry if that was off screen. So we want to, what we have available to us in MathML and really XML across the board, so HTML and so on, is this attribute of form prefix, which lets us know that in fact this leading operator here, it's really an indicator, takes a prefix form as opposed to an infix form. Okay, so if I don't do prefix rather, we can see how that's essentially treated like a regular operator, right? So I've got prefix. I could do infix, and again, that would be the attribute for just a regular operator, if we ever need to put it in there for some reason. But in this case, it's a prefix operator. Okay. All right, and let's just change that to 4. Okay, so we've got that. And really, we could leave it right there if we wanted to, but in most math courses, I just mean outside of aligning this row with the preceding rows. But the last step that we'll do is factor out the minus symbol, okay, so the negative sign, and then we'll pretty much be done. So let's go ahead and do that. Let's go ahead and align this row first. Okay, and like we stated before, we have a few options. We can put in a spacer operator, and in fact, that's probably what we'll do, but might explore another option in addition to that. So let's go ahead and put in this spacer. Okay, and so now we would be a bit creative in terms of what we actually need. So first thing I might try is just putting in 2 of these empty space HTML entities, and that's getting us closer. So I might just put in a third, see how close that gets us. So that looks to be dead on. All right. And then we might just flesh this out by saying, giving this operator some attributive annotation. And I might just say, let's see. Yeah, so we'll just say align. All right. Good enough. And then, of course, as usual, we would, in fact, flesh out some of these tags to improve our alignment, to prove the stack alignment. But I won't worry too much about that right now. So lastly, let's just go ahead and factor out the constant that makes it so that the numerator and denominator each have a prefix minus. Okay, and so the way we do it is just by factoring out -1 over -1, essentially. Okay, so let's go ahead and do that. And the quickest, most straightforward way to do it is to just duplicate this row that we just created. All right, there we go. And in this case, we're going to get rid of a couple of items. We're going to get rid of this prefix. Yeah, and so the question is how much of the algebraic steps do we want to show? Yeah, and in fact, I am going to skip a couple of steps here just to keep the video somewhat short. So I'll do that, and then of course all we have to do now is change this operator here to a minus. And that ought to do it. Oh yeah, and so lastly we'll just have to adjust the spacing functor. Okay, so the alignment control. Okay, and that is pretty close. And you see that because each row has a sort of, unique row length or line length, right, determined really by the characters on that line, this way of doing alignment control is not pixel perfect. However, it's close enough. So what I'll just do here is add to see if we get, in fact, we might just change that to a thin space, and that's pretty good. Okay, it's not pixel perfect, but it's pretty good. So I think that's convincing enough in terms of the utility of math-align-group. And again, it's something that still needs to be fleshed out and sort of included as feature of functionality in most rendering engines, but good enough for now. All right, if you have any questions or confusions or suggestions with regards to this approach to solving a block equation using MathML with math-align-group and math-align-mark, please leave a comment in the comment section below, or reach out to me via direct message on any of the platforms. And otherwise, if you like this video, please consider giving it a like and subscribe to the channel. And I'll see you in the next one.